Hello everyone. In today's video, we are going to learn Euler's theorem. What is Euler's theorem and what it is used for? Euler's theorem states that a power phi n is equivalent to 1 mod n. Now, what does that mean? It means that when a to the power a certain phi n is divided by n, the remainder will be 1. Now, I hope you all know about the remainders. So I'm directly moving to Euler's theorem and I'm explaining what is phi n. And using this particular property, we'll find out what is the value of what is the remainder when 5 power 81 is divided by 48. First of all, let us try to understand what is phi n. Phi n is known as Euler's torsion function. Now it gives the number of positive integers less than n that are co-prime to n. There are two things. Number of positive integers less than n that are co-prime to n. For example, if I take 15, then all those numbers which are co-prime to 15, 15 can be written as 3 into 5. So any number which is not divisible by 3 and 5 are co-prime. For example, we can take 2, we can take 4, we can take 7 and all these numbers. These are known as co-prime numbers which have nothing in common. So this phi n, which is known as Euler's torsion function, will calculate this. How many such numbers are there? So Euler said that a to the power phi n when divided by n gives 1 as remainder. Now let us see how to calculate phi n. To calculate phi n, the formula is n 1 minus 1 by p, 1 minus 1 by q, and now what are pq? PQR are actually the factors, prime factors of n. They are prime numbers, prime factors of n. And now let us try to understand, let us calculate one of the number. Let's say 40. Now 40 has two factors. 40 can be written as 2 power 4 into 5. So it has two prime factors, 2 and 5. 40, 1 minus 1 by 2 and 1 minus 1 by 5. So this gives me 40 into 1 by 2 into 4 by 5. 5 adds up 40 and 2 4s are 8, so 16. So any number you take, say let's say 3 power 16, which is 5 into 40 divided by 40, will give you remainder as 1. 3 power 16 when you will divide by 40 will give 1 as the remainder. We can check also. 3 power 16 can be written as 3 power 4 divided by 40. Now 3 power 4 is 81 divided by 40. 81 when divided by 40 will give 1. 1 power 4 is 1. So we have checked also. Now it is important that a number should have power as phi n, which is the number of coprime less than the number. Now let's use this property to find, let's take an example, 3 power 40 mod 25. So first of all, calculate torsion function of 25, which is equals to 25 into 1 minus its prime factor. 25 has only one prime factor, which is 5. So torsion function of 25 is 25 into 4 by 5. Cancel out this. This gives me 20. So 3 power 40, 3 power 20, which is 5 into 25 divided by 25 will give a remainder 1. Now 3 power 40 can be written as 3 power 20 square divided by 25. It will give the remainder as 1 square, which is equal to 1. So this function, Euler's theorem gives a quick method to calculate the remainder. Now, coming back to our original question, 5 power 81 when divided by 48. So first of all, the thing is we have to calculate 5 into 48. 48 can be written as 16 threes are, which is 2 power 4 into 3. So quotient function will be 48, 1 minus 1 by 2, which is prime factor of 48, 1 minus 1 by 3. 48 into 1 by 2 into 2 by 3. Cancel out. This gives us 16. Again, this value comes out to be 16. This is just a coincidence that for 40 there was 16, but for 25 the ion value was 20. So 48 again it is 16. Now we have to calculate 5 power 81 when divided by 41. What will be the remainder? So we know that 5 power 16, which is the quotient function of 48, will give 1 as remainder. Now 81 can be written as 5 power 16 into 5. 16 5 is 80 plus 1. Now this can be written as 5 power 16 to the power 5 and another 5 power 1, which is for this one. Now we know that 5 power 16 when divided by 48 will give 1 as remainder, and 5 power 1 divided by 48 will give 5 as remainder. 1 power 5 is 1 into 5. So the final answer is 5. Answer of this question will be 5. We have done this question using Euler's theorem.